Now let's talk about very important thing about strings. Strings are final in Java and hence are immutable. So if we make any variable final, what does that mean? Which means that we cannot change the content of that particular variable in our code. So if I'm saying strings are immutable, it means that once created, you cannot modify content of string. So the modification could be anything. So let's say if we apply two lowercase operation on a particular string, or if we try to do two uppercase. So if we try any method which is modifying the content of the string, then let's see what happens. So let's take an example of substring. So here we have string s prep bytes. So when we do s dot substring 0, 3, which means that we are taking out a substring out of this particular string. So someone might think that the substring that's created is assigned to s, right? Or it might be the case that s is getting modified, but the content of s is modifying, but nothing like that happens. So if you print s after this particular operation, you will get the output as prep bytes. Similarly, if we have s here having value as prep bytes, if we have s here pointing to prep bytes and we do something like s dot to lowercase, then obviously we get a new string. And if we do to uppercase, we get a new string again, but the content of s remains the same. The s still is having the value as prep bytes. So now what is happening to the new strings that are getting created? What is happening to these? So let's say the case of substring, initially we had a string prep bytes and s object was pointing to this particular string. When we create a substring, a new string is created in the string pool. It's not that the content of s is getting changed. The content of s still remain prep bytes. It's just that every time we are modifying, we're trying to modify the content of s, a new string is getting created. So this is how the new strings are getting created. So one thing you should note is that if you try to do some operation, the original string remains as it is, the new string gets created. Now the question is, why are strings immutable in Java? So let's see a few reasons that why strings must have been immutable. So the very first reason is string pool. So let's say we have a string pool and we have a string called prep. So let's say I create string s1 equal prep. Okay. And now let's say I again create a string called prep. Okay, let's say this is capital P. So now both S1 and S2 are pointing to the same string, right? So if you make any change in this particular content, then S2 thinks that the content is still prep. But if you do something like this, let's say that, let's say S1 dot to lowercase, then the content changes to prep. So now since both S1 and S2 are pointing to the same string, what happens is that though S2 didn't want, or maybe S2 is not aware that the content has changed. So just to maintain that if multiple strings are pointing, if multiple objects are pointing to same string in string pool, then changing the string will lead to some unwanted results. So makes sense to make strings immutable. Now let's proceed to the another reason. Another reason is thread safety. Again, let's say we have two threads T1 and T2 and we have a string S1. So let's say T1 changes the content of S1. So if T1 changes the content of S1, or if let's say T1, T2 try to change the content of S1, so in that case again we might get unwanted results. So if multiple threads are accessing a particular string, then changing the content of string would have led to some unwanted results or some. That's why again it makes sense to have strings as final. Third one is security. So we often pass our passwords and names and email IDs as strings. So let's say someone hacks your account. So let's say someone gets into your code and changes the strings. So if we have, let's say, password, equal to, let's say, some string ABC. So if someone gets hold of this particular PWD object and someone tries to do something nasty, no matter what the person is trying to do, the change of content won't happen. So let's say the person tries to change the password using this. And we know that if the person tries to do this, then a new string gets created and this remains intact as it is. So this is one of the reasons. And we also have something called hash code. So in maps, we generally use strings as keys. So we use strings as keys in maps. So what happens is that these strings are converted into hash codes and they are cached for faster operations. So if I create a map and I have some string, let's say prep, and it has a corresponding value, let's say, then hash code of prep is stored, is cached, such that next time when we have to find the key prep, it is easier for me to go through the map and it is faster actually. So again, if we try to change this particular value, then obviously the hash code will change and again it will lead to unwanted results. So these are few reasons which tells us that why it is okay to have strings as immutable in Java. Now we will see one of the major problems that we face because of immutability of strings and how that problem is taken care by string buffer and string builder. So let's talk about string buffer and string builder, but before that, talking about what problem comes up because of the immutability of strings. So now, since string is an immutable class, every time a new string is created and the older one is discarded, it creates lots of temporary garbage in the heap. So let's say we have prep in the heap. Now let's say I do the operation of two uppercase. And now let's say I don't have to use this particular string, prep. I have to use this particular string. Now let's say I convert this to lowercase. A new string is created. So as you can see that every time we are modifying the string, a new string is getting created and hence lots of garbage is getting generated. So we needed a way in which we can change or modify our strings. So the answer to this is string buffer and string builder. They both are quite similar except one difference. We'll talk about that. So string buffer is an older class, but string builder is a relatively new class added in JDK 5. So now we will try to understand the difference between string builder and string buffer, and obviously we will also understand that what is string buffer and string builder. Now let's talk about string buffer. So as the definition says, string buffer are mutable counterpart of strings. So the mutable word itself suggests that string buffer can be modified, unlike strings which cannot be modified. Going forward, string buffer may have characters and substrings inserted in the middle or appended to the end. So we can perform the operation of modifying the same string, and in the same string we are having characters inserted in the between, we are having some strings appended at the end. We will see how we can do the append operation. String buffer automatically grow to make room for such additions. So we will see this as well. So the size of string buffer keeps on changing based on the size of the string it is holding. So now the very first question is, somehow we know that string buffer is something that can be modified and the size of string buffer keeps on changing depending upon the characters it is holding. Okay, so now the question is, how do I create a string buffer object? So we again here have several constructors for creating string buffer object. Let's start and see them one by one. So this is one constructor that creates an empty string, obviously. So we have str getting created, which is obviously pointing to an empty string. So here, whenever we use this constructor, we get a string whose length is 0 and capacity is 16. So here in this case we have two things. One is length, another is capacity. So we will see the difference between them. So in this case we have an empty string whose length is 0 and capacity is 16. Now let's say I want to append something on this particular string. So let's say I do something like str.append prep bytes. So this append is the method using which you can append values as it is sent to the end of the string. So if we print str after this, we get the output as, okay. Now let's say we do the further modification. Now let's say this is my string till now, prep bytes. I again append prepare to this. So my string now becomes prep bytes prepare, and it is the same string. It's not that the new string is getting created every time. The same string is getting modified. Now let's say I append a character. So this is how we can append a character at the end of the string. So this makes this particular string. So this is now the complete string. Now let's say I want to append an integer. So if we do something like str.append 1000, then this 1000 is converted to string, and that is appended at the end of the original string. So this is how we can modify the strings using Strinbuffer. This is how we create a string object. Now you must be wondering, what is this length and what is this capacity? We will talk about it. Now let's talk about capacity versus length. So let's say I create a new object str. If I do something like str.append prep bytes, and if I, after this particular statement, if I print str.capacity, it gives me 16. As I said that at this particular point, a new string is created, a new object is created with capacity 16 and length 0. But after we have appended this prep bytes to this particular string, now our length is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So str.length gives me the value 9. So capacity is the number of characters this particular string buffer can hold, and length is the actual number of characters that it has. So it can hold 16 number of characters, and obviously the length is 9. So we saw that after this, if we take the capacity, we get 16, and for length we get 9. So what if the length becomes greater than capacity? So in this case, the reallocation happens. So it's not that if the capacity is 16, we can only get 16 characters. But the thing is that if we keep the length just as 9, let's say, if we keep the capacity equivalent to length, so every time the length changes, every time we'll have to do the reallocation. So just to avoid the reallocation every time, there is some default capacity that is given to the string buffer so that we don't have to do the reallocation again and again. Okay, now let's proceed further and see the constructors that we have in string buffer. So this we have already seen. So this creates a string with length 0 and capacity 16. Now in this case, what we are trying to do is that we are trying to create a string buffer object using a string, right? So we have created a string object which is obviously immutable, and now using string buffer, using this string, we are creating a mutable object of string buffer. Okay, so in this case, when we do this particular thing, then we get a object with length is equivalent to 9 and capacity equivalent to 9 plus 16, which is 27. So whatever capacity is there, whatever length is there, that is allocated, plus 16 is the capacity. So 16 extra space is provided. Okay, now in this case, what happens that we have a character sequence, and again using this character sequence, we are creating a string buffer object. So in this case, we have length is 9, capacity is 27. Now let's say that I want that my capacity is something else. So we can give an integer while creating a constructor which gives me the capacity as 20 and obviously the length is 0. So these are few ways in which you can use string buffer constructors. Now let's talk about string builders. String builders behave in the same manner as string buffer. The only thing is that it's not synchronized, and hence it is not thread safe, and hence it is faster. So when things are synchronized, so let's say we have an object and both threads, let's say we have several threads, let's say, are trying to access this object. So in case of synchronization, it is somehow made sure that if T1 is trying to access the object or modify the object, then T2 and T3 cannot do it at the same time. So this is how synchronization happens. So obviously if we try to access this particular scenario, then things will be a bit slower. So in case of string buffer, things are synchronized, whereas in case of string builder, it's not synchronized. So if you are making a multi-threaded application, then it is highly recommended that you use string builder rather than string buffer. So as I said, everything in string builder remains the same. It's just that the string buffer, string builder is not synchronized. Now let's see few of the constructors of string builder to see how we create objects. So this is the very first one. It creates an object of string builder. This is the second one. Again, everything remains the same. We have similar concepts with the capacity, with modifying the stuffs. And this is the third and fourth one. Everything remains the same in case of string builder. It's just that it's not synchronized. So that was about string buffer, string builder, and strings. So in one line, if we have to say the difference, then strings are immutable, string buffer and string builders are mutable, and the difference between string buffer and string builder is that string builder is synchronized.